and the title is More Applications of Exponential Functions. And we're going to answer the question, how does it grow? So question 35 says, examine the two types of investments, simple and compound interest, through other representations below. Part A, consider the sequence 1,000, 1,080, 1,160, 1,240. Does this look familiar?
Yes.
Yes, we saw this yesterday, right? In the left-hand column. Was that the simple interest or the compound interest? Simple. That one was the simple interest. And it is a sequence that is arithmetic, okay? From the first term to the second term, and then from the second term to the third term, you're simply adding 80 each time. That's what's called your common difference. And so they want you to take that information and write an explicit equation for your sequence. This one is what we call linear. It's increasing, but it's just increasing at a constant rate, okay? It's going to start at 1,000, and then every term it's going to go up by 80. Right? Part B, consider the sequence 1,000, 1,080, $1,166.40, $1,259.71. That should look familiar, right? That one was our compound. So is that arithmetic, geometric, or neither? That one is geometric, okay? Why? Because you're going to actually be multiplying to get to the next number. Who remembers what percent this one was?
2.
It was 8%. If you guys remember, it was 8%, okay? So we took 1,000. We changed 8% into the decimal 0.08. And who remembers why we have the 1 here? Not just 0.08, but 1.08. Dustin?
So we can count the 1,000.
Yes. So if you use the 1, it includes the 1,000 instead of having to add it back afterwards. Okay? So we use 1.08, not just 0.08. And then the n is going to represent whatever term. I think yesterday it was years, right? Every year it calculated. All right? Part C, how could the sequences in parts A and B be represented in investments? You guys already told me the first one was the simple interest. The second one was the compound interest. Part D says, think about the graphs of both the arithmetic and geometric sequences. Can your knowledge of the shapes of the graphs help you choose which investment to make? So this first one is linear, right? So it's going to make a line, and it's going to increase at a constant speed. This one, the variable is in the exponent, meaning it's exponential. So how's that one going to grow? Who remembers what the graph of an exponent looks like? It is a curve, and when it very first starts, it starts off really slowly, and then what happens? It takes off really quickly, and will get larger quickly, okay? So the first part A is going to give you linear. B is going to give you an exponential function. Question 36 says, below are two sequences. Interpret them as yearly account balances. Is the investment growing with simple interest or compound interest? What is the annual interest rate? And write an explicit equation for each sequence. So the first sequence is 7,950, 8,427, $8,932.62. Does anybody know what's happening there? First of all, is it arithmetic? Is the same thing being added each time? Yeah, you can tell because this one has cents and these two didn't have cents, okay? So we're going to say that it's geometric, which is going to make it compound interest. And the reason is we're going to be multiplying by the same number each time. So let's figure out what that number is. Does anybody remember from yesterday how to figure out what that is? What operation do you think we would need to use? All right, so we're going to use division to figure out what we need to multiply by. Division and multiplication are inverse operations of each other, right? So if we divide, then we will figure out what we're actually multiplying by. Does that make sense? Okay, so the way to do it is you're going to take the second term, which is 8,427, and divide it by the first term. So you're going to take 8,427 and you're going to divide it by 7,000, and that's a 9. My handwriting just got bad there. By 7,950, and here's what it looks like on your calculator. 8,427 divided by 7,950, hit the equal sign, and it tells you 1.06. Which means what percent? It means 6%, because the 1 just is the original amount of money, okay? 6% is the extra, okay? Then they want us to write our explicit equation. Our A is our original amount, or our investment amount of 7,950. Our multiplier is 1.06, and then our exponent is our variable, okay? Our next sequence is 300, 312, 324, 336. What's happening with these numbers? We're adding 12 every time, right? So is that going to make it simple or compound? That one's going to be simple because we're adding the same number each time. And then we're going to find our interest rate by doing the exact same thing we did in part A. We're going to take the second term and divide it by the first term. So 312 divided by 300 is 1.04, which makes it a growth rate of 4%. Because this one is linear or simple, our equation is going to be in simple form. So right here, I've got 288. But if you look over here, the first number is 300. So how did I get from 300 to 288? By subtracting. We subtract 12 from 300. And that means our zero term, or our starting term, is actually 288. And it's going to go by 12 each term. Add 12, add 12, add 12, add 12. Okay? All right, I'm going to move this up. If you're still writing, it'll be at the top in just a second. All right, we're at the top of page 10. Question 37 says, a third option for investing money is investing in a money market account, which offers to compound the interest more often. One example is a money market account that offers 8% annual interest compounded quarterly, which is 4 times per year. This means that the 8% is divided into 4 parts over the year. So the bank pays 2% quarterly or every 3 months. So circle the word quarterly and write 4 times per year. That's what the word quarterly means. Okay, part A. Model the quarterly value of the $1,000 investment in this money market account with an equation. Let Y represent the money in the account and X be your quarters. Okay, so the same investment of $1,000, and this time it's 2%. So the 0.02 is the 2%, the 1 is the 1,000 that we started with, and the X is going to be whatever quarter you're on. First quarter, second quarter, third quarter, fourth quarter. If it's 1 year, how many times is it going to have calculated? 4 times. So the next question wants us to find 4 years. All right. Part B, use the model to calculate the value of your $1,000 investment after 4 years. So how does this compare with your other investment options from yesterday's problem, 832? Okay, so if in 1 year it calculates 4 times, how many times is it going to calculate in 4 years?
16.
Which is it, 12 or 16?
16. I don't know.
Which is it?
16.
16. 4 times 4 is 16, right? 4 years, 4 years, 4 years, 4 years. Okay? All right. So we're going to take the 1,000 and we're going to have our multiplier be 1.02. We need it 16 times. So watch how you would type this into your calculator. So order of operations says you're going to do what first? Multiply or exponent? Exponent. So you're going to type in 1.02. You're going to hit the caret button, and then you're going to type in 16. Hit the equal sign. It gives you this big long decimal. Don't write it down. Don't even try to memorize it. Just leave it in there because now you need to multiply it. So you're going to hit the multiplication button, and it types in A and S, which is what? Your previous answer times 1,000. Hit the equal sign, and then you have to round to the nearest penny. So after the decimal, we have 78 cents, but there's a 5 next to it. So it has to go to 79 cents. So it's $1,372.79. And see what I did with my equal sign? I made it wavy. Why? Because I rounded it. Okay, because I have all these decimals in there, and I'm not going to write them all down. I'm just going to round it to the nearest penny. Okay? And they want to know, how does this answer compare with what we got yesterday? It's going to be higher than the one from yesterday because it's calculated quarterly, not just yearly, even though it ends up being the same percent. 2% 4 times a year is 8%, but if it's calculated more often, then it's going to end up being more. Okay? Question 38 says, you have $500 to invest and have several options available to you. Part A says your banker shows you the graph at right to explain what you can earn if you invest with him. Does this graph represent simple or compound interest? Simple, right? Is it going up? Yeah, that's good. But is it growing by the same amount each month? Yeah, it's a constant rate, okay? So this one is definitely simple interest. And what is that interest? What is that interest rate? And they want us to write an equation to represent how much money you would have as time passes. So we know that it was $500 invested, and after year? Yeah. After 1 year, then it's at 600. So it goes from 500 to 600. So I'm going to say that, or I'm going to take the 600 and divide it by the 500. That's going to give me a rate of 20% because my calculator spits out 1.2. Okay, 20% is pretty good. But it's the same amount being added every year. And that same amount from $500 to $600 is how much? $100 even. So our equation is going to be 500, the original amount invested, plus $100 every year. Part B says, Jerry says, I've got my money in a great account that compounds interest monthly. The equation, y equals 388 times 1.008 to the m represents how much money I have made at the end of any month. Okay, so how many months in a year? 12. Okay, so watch what you're going to do. If they're saying his rate is 0.008, we need to move that decimal point how many places to the right? 2 places to the right, which makes it 0.8 every month, but there's 12 months. So 0.8 times 12 means that it's actually 9.6% interest rate for the year. Is that better than 8? Especially when it's compounded monthly. So it's going to be compounded 12 times. And even though it seems like a really